Alright, moving on. Next problem is on our function transformations review. 13 here, we need to take a function here and translate it horizontally plus 3 units. We need to get the new x-intercept. Well, you need to know what your original x-intercept is. So if you're not sure, you can always just put 0 here and solve for x. Because remember, the y value at the x-intercept is 0, so if you put 0 there and you solve for your x, you'll have your x-intercept. So add 8 to both sides, divide by -2. Your current x-intercept is -4, and we need to translate it horizontally 3 units, so -4 plus 3 is going to give us a new x-intercept of -1. This guy here is being translated vertically 2 units. What's the new y-intercept? Well, originally the y-intercept of 2 to the x is 1. The y-intercept for, just normal positive integer to the x value, positive number to the x value is 1. Well, it's already been translated down 1, so its current y-intercept is 0. But we need to translate it 2 upwards. So 0 plus 2 is going to give us a new y-intercept of 2. Moving on to 5. Again, that has a y-intercept of 1. Adding 1 there, we're going to have a y-intercept of 2. And when you translate vertically 5 more units. Oh, this one's asking about horizontal asymptote. My bad. This guy normally has a horizontal asymptote of y equals 0. But if you add the 1 there, you're going to have a y equals 1. But we need to translate vertically 5 more units. And so if you got 1 plus the 5 there, you're going to get 6. And so y equals 6 is going to be your new horizontal asymptote. If you have this guy translated vertically -2 units, that'd be 3 to the x minus 4 minus 2, which is 3 to the x minus 6. The new horizontal asymptote is going to be this number here. Well, y equals that number, because horizontal asymptotes are y equals 1. On 17, here we have this lovely function going on. But even if you times 3 in the front there, the horizontal asymptote is still going to be the same. And so this has a horizontal asymptote of 0, but adding 5 makes it 5. And when you translate it vertically -1 unit, you're going to get 4. And so y equals 4 is your new horizontal asymptote. Here I need to do -4 times the function. That actually doesn't change the horizontal asymptote. Your graph is just going down, but it is still just an exponential that has an asymptote at the x-axis, which is y equals 0. But when you move it up 1, you're going to have a horizontal asymptote of 1, and then when you translate it vertically +3 units, you're going to get 1 plus 3, which is 4, so y equals 4 is the new horizontal asymptote. Moving on to 19, and hopefully to the end. You got this function here that's been graphed, it's beautiful, and you find the value of k. Well, k is a vertical shift, so you need to know what the original one would look like, which actually it looks like this graph here. K starts at the origin, has a y-intercept of 0, but it looks like it's been shifted up 2 values, and so k would have to equal 2. On 20, we're going to have our graph would start here and go up like so, but its y-intercept, which used to be 1, has been shifted down 2, so it's looking like k is going to be shifted down 2, or subtract 2. And then on these next ones, you have this lovely function. It's awfully beautiful, and we're going to get to that in just a second because I don't want the video to go much longer.